Uh, Hi guys, update this side. So welcome back to my project 2, day 2, actually day 6 of my series 25 projects in 100 days. So I made few progress. I will show you. So tomorrow I already show you this filters that I made by using CV2 color maps. Today I use auto encoders, which is a model that I'm going to use to make the images more precise and accurate to look at. Initially, I'm taking 25 labels with each 100 images, but now I'm taking only one class with 1000 images, which is of airplanes. So as you can see, this is the code, and this is the counter that I put so that it can the for loop will get stopped. The 20% of the 5000, which is 100. Now here I'm not converting the images into grayscale. I'm converting them into a channel, blue channel, which is, I will show you this channel. Now what I am doing, I am converting main image into the B channel, and now from the B channel I am going to predict the main images with the help of these two. That's what the main plan of today's. So these are the images. So basically what it is doing, converting all the colors, all the vibrant colors to the blue and the blue colors to the red. This is what actually going on. And then grayscaling the same things, I printed them. Then after that, I split the data set into 800 to 200. This is the shape that I am going to use for my model to get trained on. This is the definition of a model. I'm using UNet architecture. So this is just a downscaling layer. This is upscaling layer, and this is the main architecture that I learned with the help of a few videos and the forums. I will share everything on the GitHub. These are the parameters that I am getting, 9.6 million parameters, where 2.5 are non-trainable. Then I compiled the whole thing and then fit the whole thing. I only used 50 epochs this time and got an accuracy of almost like 83% in the end, which is really good. And save the model with using job. What it does is it save the model in the PC itself so that it is easier to post it over GitHub. Or you can save directly with the help of Keras libraries. So this is it is getting saved. I made this function. What it is doing is printing these three types of images, which is color image, grayscale, and the prediction ones. So it is very easier to do so. See the color image is, this is not actually green scale image. Green scale image, it is like a blue channel image, and this is the predicted image. You can directly see the graininess in this, and you can see the color are getting pretty good because in blue scale we can directly see the difference between the colors and stuff. So this is what I did on the first model what I trained on today. Then I got to a proper grayscaling model one. So what I did is proper grayscaling this time and trained the model itself with the same thing that are above, and we got accuracy of around like 58%, which is not that bad in general because we are coloring the images, and accuracy does not even matters in this case because we have to analyze with the help of the prediction image and the original black and white image. So this is the colored image. Oh, sorry, this is not a colored image. I'm using the same function from above. That's why it is showing color image. It is a black and white image, and that's why it does not get converted into grayscale. And this is the prediction image that we are getting, which is really good. You can see the blue colors, yellowish, and a little bit of shade here. And then I also predicted with some of the images from the main training set, you can say. These you can directly see the patches that are not getting colored, but you can see the main grass. It is doing a perfect job. You can see it is making them green. This is the concrete, and then it's making it to a green. Uh, Then this is the another image that I downloaded from the internet, and then look at that. The prediction is pretty good from my opinion. Then I use this few of the library is to get a more enhanced version of the for the picture itself. You can directly see this. Uh, and I also downloaded like a man, like a person sitting in the on a bench and trees. You can see the green colors are coming from the trees, but not like on person because the model is trained over like an aeroplane model. And how can it convert images with of a person into a normal colored images? So you can see it is doing like okay, not like a huge um, success in general. Then I trained on a boxing ring images, which is another model that I have. So the same thing, these are some images, and I just do the same thing from above. Then we got an accuracy of 69%. This is good. Now after that we evaluate the model and then get accuracy of 62%. This is like very good in general. So you can see this image that we converted above, it converted to like a stormy area. So look at this. This is predicted by this model, boxing ring ones, and this is from above. You can see it looks more realistic as compared to like this with multiple colors and stuff. So that's what I did today. The whole thing, it has more yellowishness as compared to like above, which has like a more bluish color. Then I downloaded few more images from the internet and see how they can be converted movie scenes. And yeah, that's all I did today. I am pretty happy with the colorization from these images. You can see here, this is the boxing ring model, which converts it to like more yellowish color, and this is like the above airplane model that converts it to a more natural one. So, like if we train our model on like more natural things, like maybe more grasslands and stuff, then we can get more accurate results. I think I will try that tomorrow on the collaboratory and see how well we can perform. Thank you for watching. Bye.